In this lesson, I'm going to go over the three major tools that you use during geometric constructions, things you can do, things you cannot do, and also go over the four basic types of geometric constructions. There are more that we will discuss later. First of all, first tool I want to talk about is a compass. The compass, notice, does not have to have any measuring tools on it, although some do, but the important thing is that when you open or close the compass and you leave it alone, it doesn't move, meaning the openness doesn't change, because the key to using a compass for constructions is that when you open or close it more, that it can retain that degree of openness. This is a protractor, but what I'm really going to use on the protractor is this part. This could be used as what is called a straight edge. A true straight edge would not have any measuring marks at all. But really, as long as you just use this and you don't measure with it, then it is part of a construction. A geometric construction cannot be made measuring using coordinates. The other thing is just a writing utensil. We normally use a pencil. Now, the first thing we're going to do is the construction called copy a segment. So what I would like for you to do is, with your straight edge and your pencil, is to just simply make a segment. Do not worry about measuring it. In fact, you should not measure it. You should just leave it the way that it is. And it does not have to be the same length as mine. We're going to copy this, meaning we're going to make a congruent segment. And to do that, since you have a straight edge and you have a pencil, you can make a segment. You just can't guarantee that it's the same length. So what I would like for you to do is to make another segment, but go ahead and make sure that it is much longer than the first segment. In constructions, what you actually use for measuring, without using numbers or anything like that, is the compass. And many architects and people who do drafting on pencil and paper, they actually use a compass to do this many times rather than measure in this way when they're making their scale drawings. Take the sharp end, place it on one end point. Take the pencil, place it on the other end point. Try your best to get it as close as you can. And then go ahead and make a little arc so that you see it go through the end point. Without changing the openness of the compass, bring it to your other segment. Place the sharp end on one of the end points. You could put it on the right or the left. And then take that pencil and make an arc again. Since you have not changed the openness of the compass, the distance between this point and this point has not changed. So, when you make this arc, the distance between this point and this point must be the same or equal to this point to this point. So you have from here to here is a congruent segment with this, because if the two lengths are equal, then the segments are congruent. And again, that's called copy a segment. The next one, we are going to bisect a segment, meaning that we are going to find the midpoint of the segment that cuts it in half. So again, just take your straight edge and your writing utensil, and you're actually constructing a segment there. Don't worry about the length of it, just don't make it too short, because if you make it real short, it's hard to use the compass. Now the key to this is to make sure that you open the compass. I'm going to close it a little bit, but you want to make sure that you open it so that it is more than halfway across. You can predict where it's halfway, but you can't find the exact halfway point just by putting the point there. You might get pretty close, but it would be hard to do that. But you can easily come up with over halfway. Then you're going to take your compass, sharp end on the end point with the pencil, and make an arc. And make sure that you go pretty far above and below the segment without changing the openness. Place the sharp end on the end point and repeat. And if you have placed it over halfway, then you'll get 2 intersection points. If you do not, they will not intersect each other. The final thing you do, you take your writing utensil, you take your straight edge, you place the straight edge so that you can make a segment that goes through 2 intersection points for the 2 arcs. Later we'll talk about what this segment is, but for now I want you to realize that the point of intersection will be the midpoint between these 2 points. So you have therefore bisected this segment. You have cut it in half. So this construction we refer to as bisect a segment. Now I'm going to do a construction related to an angle. What we're actually going to do is copy an angle. So the first thing I'm going to do is construct any angle. You can do acute, right, obtuse. It really doesn't matter. I'm going to do an obtuse. Okay, so here we have our angle. What I want to do is to make a congruent angle. That's what copying an angle essentially means. So down here, to get one of the sides of the angle, I'm going to simply draw a segment. Now keep in mind that I've drawn this side from here to here, but because an angle goes on forever, it's a ray, I don't really have to worry about it being the same length as this one. What matters is the degree of openness. So the next thing I'm going to do is take my compass. I'm going to set it up so that it is open to the point where I could make an arc that goes and intersects both sides of the angle, like so. Now, I'm going to, without changing the openness of the compass, I'm going to place the sharp end on an end point of the segment. I'm picking the left, but it could be the right. And I'm going to sort of mimic that arc. Now, at the same time, I'm sort of realizing that I know that I have an obtuse angle, so that means I want to go over far to the left. I also need that point. So all of these points are the same distance from this point. All of these points are the same distance from this point. In fact, those 2 distances are equal. Now what I want to do is, you can change the compass openness, place the sharp end on one of these intersection points, and place the pencil on the other one. So I've measured that length. Now I know one of the intersection points is here, so that's where the sharp end needs to go. And then you take it and take the arc, and what should happen is you should have an intersection point right there. Okay? Now what's unique about this point is that it is the same intersection point corresponding to this one. So since I already have the vertex, if I take a straight edge, take my writing utensil, I'm a little off. I should have looked at it a little more. So this is probably going to be a little bigger than that. But if I could get through that exact point, these 2 would be congruent. And again, remember what I said before. It doesn't matter that this length is longer than this one. These are rays, so they go on forever. This is called copy and angle. Okay. For the final construction, I'm going to bisect an angle. So this time I will make an acute angle. And since I'm not copying the angle, I just went ahead and got closer to the middle of the page. Okay, what I'm going to do is take my compass, set it where it would be easy to do this. Place the sharp end on the vertex, and again make an arc that goes through both sides of the angle. This is where it seems to get a little weird, but what I need is a point out here that is equidistant from both of these sides, or equal and distant to. And where I'm going to get that is start with these 2 points that are the same length away from the vertex. So it's okay right now if you move your compass for this next one, but in most cases you don't have to unless you were very small in your openness. You're going to take the sharp end and go to one of these intersection points. It doesn't matter which one, you're going to end up using both. And then make an arc inside the angle. Make sure you're pretty confident that that arc would contain the point that would be halfway between these two. And then, without changing the openness of your compass, place the sharp end on the other intersection point and repeat the process. And you should get this weird looking X. Well, that intersection point, that weird looking X, is a point that's on the angle bisector. So you can take your straight edge, line it up with the vertex and the intersection point, use it to draw that ray so you have the construction. And if everything is done correctly, that ray will bisect this angle. So for example, if this was 40 degrees, these two would both be 20 degrees.